Close your eyes for a moment and imagine darkness. Not the darkness of a room at night, but the darkness between things, between particles, between worlds. Now open them. Look up. Somewhere in that vast ceiling of stars, there's a faint smudge of light. You might miss it if you blink, but that smudge contains 1 trillion suns, each one burning across a distance so profound that the light reaching your eyes tonight left before your ancestors learned to speak. 1 trillion suns. That's more stars than every human who has ever lived, for every second since our species began, and all of it compressed into a smudge you could cover with your thumb. This is Andromeda, and tonight we're going there. Before we understood what Andromeda was, we first had to accept how wrong our sense of distance could be. For most of human history, we didn't know what we were looking at. That pale streak in the autumn sky seemed delicate, almost fragile. Persian astronomers called it a nebulous smear. European scholars thought it was a cloud of gas drifting somewhere inside our own galaxy. They were wrong about the distance by a factor of millions. The truth, when it finally arrived, was unsettling. In the 1920s, an astronomer named Edwin Hubble measured the light from stars within that smudge and realized something profound. Those stars weren't nearby. They were impossibly, incomprehensibly far away, more than 2 million light years from Earth. What we'd been calling a nebula was actually an island. An entire galaxy, a structure so massive it made our Milky Way look modest by comparison. And suddenly, the universe became unimaginably larger than anyone had dared to believe. That revelation changed everything. Because if Andromeda was a galaxy, then so were all those other faint smudges scattered across the night sky. The universe wasn't just our galaxy. It was thousands, millions, perhaps billions of galaxies stretching in every direction. We had been living inside one room of an infinite mansion, convinced the room was all there was. So what would it take to cross that distance? To leave the Milky Way behind and arrive at Andromeda's doorstep? First, you'd need to escape. Rising above our galaxy's spiral arms, you'd watch the stars thin out. The familiar constellations would blur into a soft glow behind you. Eventually, you'd pass the last outlying stars, the ghostly satellite galaxies that orbit our own. And then, silence. Intergalactic space is emptier than anything we can truly imagine. On Earth, every breath you take contains 10 trillion atoms. In the space between galaxies, a cubic meter might hold only 10 atoms. It's not quite nothing, but it's as close as the universe gets. Out here, you'd find no landmarks, no reference points, just voids stretching in every direction, punctuated occasionally by rogue stars ejected from their galaxies by ancient collisions. If any planets orbit those stars, they are the loneliest places in existence. No nearby suns, no galactic glow, just endless cold. The journey would take you more than 1 million light years. Even traveling at the speed of light, you'd spend over 1 million years in transit. 1 million years ago on Earth, our ancestors were still learning to control fire. Think about that for a moment. The entire span of recorded human history wouldn't even register as a blip in this journey. Halfway through, something changes. The void begins to feel less empty. You're entering Andromeda's domain. Not the galaxy itself, not yet, but its atmosphere. A halo of superheated plasma, flung outward by ancient collisions, surrounds Andromeda like a massive, invisible shell. This halo extends over 1,000,000 light-years from the galaxy's center. It reaches more than halfway back to us. Within this plasma cloud, you'd encounter Andromeda's satellites. Small galaxies orbiting their massive host. Some are intact, still forming stars. Others are little more than cores, stripped of their outer layers by Andromeda's gravity. One of them, called M32, tells a particularly tragic story. It's small now, just a golden elliptical smudge. But the supermassive black hole at its center suggests it was once much larger. Perhaps a spiral galaxy in its own right. Andromeda tore it apart, absorbing its outer stars, leaving only the dense core behind. Imagine being a civilization on a world inside M32 as this happened. Watching your galaxy being slowly consumed, your sky filling with the light of your destroyer. Now it orbits Andromeda like a ghost, a reminder of what happens when galaxies come too close. Finally, after crossing an ocean of darkness, you arrive. Andromeda's outer edge resolves into individual stars. Scattered dim, flung outward by the chaos of past collisions. But as you move inward, the stars grow denser, brighter, more organized. You enter the visible galaxy, a barred spiral like the Milky Way, but larger, over 200,000 light-years across if you count its full extent. Home to more than 1,000,000,000,000 stars, its spiral arms aren't clean or symmetrical. They've been warped, fractured by billions of years of gravitational battles with neighboring galaxies. In some places, the arms break into segments. In others, they overlap into rings. It's a structure shaped by violence, by collision, by survival. Within those arms, vast clouds of gas and dust collapse into new stars. One cloud, called NGC 206, stretches 4,000 light-years across and glows with the light of hundreds of massive blue giants. Each one is dozens of times wider than our sun, burning through their fuel at a ferocious rate. They'll be dead in a few million years, but for now, they illuminate the galaxy's spiral architecture like cosmic lighthouses. Scattered throughout Andromeda are globular clusters. Dense spheres of ancient stars, some containing millions of suns packed into regions just dozens of light-years wide. Andromeda has over 400 of them, 3 times more than our galaxy. These aren't just beautiful structures. They're time capsules, preserving stars that formed when the universe was young. And then, at the very center of Andromeda, something peculiar. The galaxy's core isn't a single nucleus. It's double, 2 bright concentrations of stars orbiting each other. One is offset, a disk of brilliant stars circling the true center. The other sits at the heart of the galaxy, anchored by a supermassive black hole. That black hole is massive, over 100 million times the mass of our Sun, 25 times heavier than Sagittarius A star, the black hole at the center of the Milky Way. It grew this large by feeding. Every time Andromeda consumed another galaxy, gas and stars funneled toward the center, feeding the black hole, making it larger, more powerful. It's a monument to consumption, to survival, to 10 billion years of cosmic warfare. You might think this is a journey we'll never take, that Andromeda will always remain a distant smudge in our sky, unreachable. But that's not quite true. Because Andromeda is moving toward us. Look closely at images of the galaxy and you'll notice something. A faint blue tint. That color isn't natural. It's blue shift, a Doppler effect. The same phenomenon that changes the pitch of a siren as it approaches. Andromeda's light waves are being compressed because the galaxy is racing toward us at 110 kilometers per second. Not because of some cosmic catastrophe, but because of gravity. Our galaxies are close enough that gravity has overcome the expansion of the universe. We're falling toward each other. In 2 billion years, Andromeda will be larger than the moon in our night sky. In 3 billion years, it will dominate the heavens, a sprawling structure of light and gas stretching across half the sky. In 4 billion years, the two galaxies will collide. It won't be an explosion. It will be a slow-motion waltz. The galaxies will pass through each other, their stars too far apart to actually collide. But gravity will warp everything. Spiral arms will be torn apart. Stars will be flung in every direction. Our sun might be thrown into intergalactic space, or pulled toward the center, where the two supermassive black holes will eventually meet. When those black holes collide, they'll send ripples through space-time itself. Gravitational waves powerful enough to be felt across billions of light years. And from their merger, a new galaxy will be born. An elliptical giant with no spiral arms, no star-forming clouds. Just an aging population of stars, slowly burning out. They're already calling it Milkomeda. This new galaxy will gradually absorb the smaller galaxies around it over billions of years. Star formation will slow, then stop. No new suns to replace the old. The galaxy will age, its stars cooling, dimming, one by one. Meanwhile, the expansion of the universe will accelerate. Distant galaxies will recede beyond the cosmic horizon, their light stretched into invisibility. Milkomeda will be alone in an expanding void. Over quadrillions of years, the stars will die. The last red dwarfs will flicker out. The white dwarfs will cool to black. And in the end, there will be nothing but cold, dark, inert matter drifting through an expanding void. The story of Andromeda and the Milky Way will be over, but we're not there yet. We're here now in the middle of the story. Long after the chaotic birth of galaxies, long before their quiet death, we can still see Andromeda in our sky, still photograph its stars. Still wonder what it would be like to walk on a world within its spiral arms, looking up at a sky filled with 1 trillion suns. For 100,000 years, humans looked at that faint smudge and didn't know what it was. For 100 years, we've known it's a galaxy. Imagine what we'll know in another 100. The universe is vast. Andromeda is vast. But the questions we ask, the curiosity that drives us to look up and wonder, those are just as vast. And maybe that's enough. Look up tonight. Find that faint smudge of light. And remember, you're not just looking at stars. You're looking at a future. A collision billions of years away. A story that's already unfolding, written in light that left those distant suns before we existed. We are here now, witnesses to something enormous. Something ancient. Something still moving toward us, slowly, patiently, across the dark.